Hello folks, here is a QD question that I didn't solve in class. I want to post this video for you guys to see. This question is telling us, in the spot of dock, jumping dogs run at full speed off the end of a dock that sits a few feet above the pool of water. The winning dog is the one that lands farthest from the end of the dock. If a dog runs at 8 meters per second, so dogs are jumping from the dock and landing here. One dog jumps with a 8.5 meters per second. That will be the initial velocity and the initial x component, because there's no y component. So the whole velocity is along the x component. I'm going to change the blue here. And let's keep reading. So 8.5 meters per second straight off the end of a dock, and is 0.61 meters above the water. So we know the height here. We can call this h, or we can call this delta y, to be in line with the book. So we know the height. How far will the dog go before splashing down? Would be the distance the dog would travel along horizontal, delta x. What we can do here is, remembering that we have a long horizontal constant velocity motion, so the horizontal equations will be x final is equal to x initial plus vx initial delta t, and that's it. And along vertical we have free fall, and we'll have one equation, y final is equal to y initial plus vy initial delta t minus 1/2 g t squared, minus here because it's coming from the fact that we have acceleration along y, ay, and ay is always equal to minus g. So we're gonna need to find this x final. I can call this position x initial, take it to be 0 as always, call this position y initial, take it to be 0, then this position here will be y final, and the height is 0.61 meters, means our y final will be minus 0.61, and the minus is coming from the fact that we took this position to be 0, so anything down will be minus. And along x, we call this x initial 0, x final, we don't know which is what we're looking for, because the distance between x initial and x final, which will be delta x, right? That's what we're asked to find. Delta x is equal to x final minus x initial will be equal to x final in this case, because x initial we set to be 0, which is something we can always do. So what we need to find x final. We took this to be 0. We know vx initial, because along horizontal our velocity never changes, so we will always have this vx initial to be the same, and this actually will keep being equal to v initial. So initial velocity was only along x, remember? It will come down here with the same vx initial. So all we need to find is the time, and how we can find the time would be this equation. We initial we set to be 0. Y initial will also be 0 because the dog jumps along horizontal only initially. So y initial is 0, that term also goes to 0. Now y final we said would be equal to minus 0.61, right? So we have everything to solve for this t, or I'm gonna call it delta t again. We can go ahead and call this t as well, similar to x value here. We can call t initial to be 0, and final will be the final time, which could be t, but we'll keep this delta t to be in line with the book again. Now for this type of situations, if you have initial vy0, always go with this to solve for the time, and the time you find will always be equal to this. When you do the algebra, which we did in class, I'm going to skip that, delta t will be equal to y final. Well, let's just do this. Let's just do the algebra. I want to leave the delta t squared alone first. I'm going to solve for delta t. So these are going to 0. Will leave me with this. Y final is equal to minus 1 over 2 g delta t squared. To get to delta t, I'm going to divide both sides by minus 1 over 2 g. Alright. Once I do this, these will cancel here, and delta t squared will be left alone, and it will be equal to, here where I have 1 over 2, and it will be inversed coming up here because I have y final over 1 over 2, so that will be equal to minus 2 y final over g. And to leave delta t alone, I'm going to take square root of both sides. So delta t is equal to square root 2y final over g. Now over here minus will cancel because when I insert by final, it is also negative under the assumptions I have. This is y0, y is equal to 0, this should be minus. Minuses will cancel. So you can always feel free to remember this equation. If y initial is 0 and y initial is 0, this equation will always hold. You can go with the absolute values of 2y final over g, and that will give you the time. You don't have to worry about negativity because it will always turn out to be positive. It should be because time is always positive. Now I'm going to solve this guy over here and get delta t. Maybe I'm going to use another color. Delta t will be equal to, now I'm entering the numbers, absolute values, so I'm not worrying about negatives. Again, if I insert this guy as negative, negative times negative will be positive, so I'll have a positive answer. So I'm just entering the absolute values because I'm sure that's what will be happening here. 0.61 divided by g, which is 9.8 meters per second squared, and that should give me an answer. Let me see if I have that answer somewhere here. I don't. I'm quickly going to find that. So that will give me a time of about 0.35 seconds. Now we're going to enter this over here to find x final. Let's do that action over here. X final is equal to, let's rewrite it, x initial plus Vx initial times delta t. Now I know everything. This guy was 0. I know Vx initial 8.5 and time is 0.35. So let's enter those. 8.5 meters per second times 0.35 seconds. Look how nicely here seconds cancels, meters is left because we are calculating the distance, and that should be equal to about 2.99 meters, so about 3 meters if we round it to one significant figures. So that's an example for you.